planned to give you the ability to read queries and to write two simple queries, rate and sum. These are my targets for this session. What is Prometheus? It's simply a database. It keeps the metrics inside, like MySQL, like Cassandra. Prometheus pulls every 1 minute from the services the metrics. So every service exposes HTTP endpoint, so Prometheus can get to it and scrape the metrics. Every DC has its own Prometheus and its own Thanos. I will explain what is Thanos. What are the best practices to monitor our system? There's the paradigm of RED. RED is rate, error, and duration. Because we're HTTP based, it's very, very relevant. We want to make sure that the error rate is low, that the successful rate is high, and the duration is as low as we want. Let me show you how we do that in Prometheus. I'll try to show you. Okay. So this is how I check my rate. The sum of the rate should be equal. If it equals 0, it's a problem. If the error rate, that are failures divided by count, is higher than 6%, it's a problem. Or if the sum of the duration is more than 100 milli, it's an error. So if one of the three happens, you see bigger than 0, then there's we raise an alert. This is an example of how we use the RED paradigm to monitor our system. I will return to this slide later on. Now I will talk about a little bit about architecture, and then so I talked about Prometheus, and I said every DC has its own Prometheus. It has more than one. For instance, in LA data center, Prometheus, both Prometheuses talk with console, and then console tells Prometheus what are the services or what are the servers. Then each Prometheus goes to each of the servers and scrapes the metrics, and it is done each minute.
So for Prometheus, it's pull architecture, not push?
Oh, you're right. Prometheus is asking for the list of services from console, and then it goes to each service one by one and scrape the metrics from it.
Thanks.
Okay. Then we have, in addition to Prometheus, we have Thanos. Together with Prometheus, we have Thanos. Thanos is not a database. Thanos acts like a high availability solution, acts like a proxy, and there is an additional Thanos in Israel that acts like a fan out ability. So if you want to do cross DC query about metrics, you need to talk with the Thanos of the cross DC. It will talk with all the Thanoses in all DCs, and then they will talk with all the Prometheuses in the same DC, same data center, and you will get an answer. So we need to understand that in this architecture, we want to know where our service sits, and we need to know in which data center to access directly. Because if we will use the cross DC, it will take time to get an answer back. For Kubernetes, like Jack asked, we have a different Prometheus. In addition to the data center Prometheus, in addition to those, we have additional ones. So we access directly Prometheus. It's very important that we speak the same language. So I'll do it quickly. A series, actually it's a shorthand for time series. What's so special about a series? It's just a list of numbers, right? No, each number appeared exactly 1 minute apart. So if the first number is 1, This is, for instance, this is a counter, a series of a counter. Let's see, and the next data point happened 1 minute after. Prometheus approached our servers and scraped the metric out of it. So the metric increment was incremented and it got a new number. And a minute after, it got even a bigger number. It means that the rate between this in this minute was higher. So each and every number represents a data point with a timestamp. Here we can see what happened. Here we can see that there was a reset. Can anybody tell me why do we see a reset here in this counter? Anyone?
Maybe a restart of the server?
Yeah, it's a restart of the server. So then, thank you, Henry. So the numbers were incremented. And if we see the number starts again from a lower number, it means that the JVM or Python service stopped and restarted. And as I said, Prometheus reads the value every minute. So I mentioned two types of metrics, a counter and a gauge. A counter is an ever incrementing number, and that sometimes resets to 0 if the process was restarted. A gauge is just an absolute number. For instance, the duration that took me to read a raw from the database, for instance. Okay, so this is the UI of Prometheus, and it's the same as the UI of Thanos. Let me show you. So here you write down the query, and here you can execute the query. Once you will execute the query, you will get your series names and labels here. And the current value of this instant that Prometheus has, you can get it in a table because you get a vector of series, not only one. You have several series for the same query, and you can see it in a graph. If you want to see it in Thanos, that's the same UI, Prometheus and Thanos. If you ask yourself, why do you show me the UI of Prometheus? We want to use Grafana because it's very useful to find your metrics right now in the Prometheus UI. Eventually, you will put it in Grafana because Prometheus UI does not have any dashboards. It's just for an ad hoc query, and it's very fast, okay? I want to talk about the basics of Prometheus. And Prometheus actually is a database. It's a multi-dimensional database. It uses labels. But you already know what about labels, right? Because you use Google Gmail, and you have labels, though. So if you want to see all the done items, you just ask for the dimensions of done, and you will get back a vector of 1, 2, 3 conversations. If you will ask for the dimension of today, you will get 1, 2, 3 conversations. If you query for the label with the value needs reply, you will get 1, 2 conversations. You get a vector of 2 items. And you can have on the same item both done and needs reply. You also know labels from Jira, right? You have this label notion or dimension notion, both in Inbox and in Jira. So Prometheus is the same like Jira and Gmail. And this is the notation. You have the metric name, and then you have the label name, and the equals label value. And this is an example. That's a metric name. A metric name actually is another label. I will show it to you. And then a label, and then a value. Label, value. Simple. Multi-dimensional database. Very, very powerful. Let's see a metric name and labels in Prometheus. It's very similar to JSON, right? But the colon is not actually a colon, is an equal sign. And the name, you can replace it with the label name. So you have equal sign instead of colon. And if you will use the label name underscore underscore name underscore underscore, you can replace the whole thing. So it looks like a JSON, very familiar. These are our labels, label 0, label 1, label 2, that Taboola Infra R&D added for us to make the transition from Metrictank to Prometheus an easy transition. And the other labels like domain and host group is added automatically by the service itself. So let's see how today we can find the labels from our code. If this is the code under dev products, we create a metric. This string will be label 0. This string will be label 1. If we had additional in the hierarchy, if we had additional strings, it would be label 2, 3, and so on. So it's easy to look for label 0 equals to this long string, and we will get to our metric. So I'm showing it here in the UI. I'm opening the curly like I do in JSON, the name of a label, the value, comma, another label name, another value, and I got a vector. Oops. And I got a vector of 1, 2, 3, 4, 5 series with this instant value. So we got an instant vector because
so it's finding all the metrics with those labels, the series with those labels.
Yes, this dimension that I just defined here, this is the result of this dimension query. And the result is a vector with 5 series, 1, 2, 3, 4, 5, and it's an instant vector because I got 5 instant value. What we have right now, this is in this instant. If I want to see less labels, you see here I got a lot of labels. Too many, like I have too many labels. I don't want so many labels. So I can ask to do a sum. It's like a group by. I ask for label 0, label 1, host group, server, and name. Name is actually the metric name. And then I open brackets and I write my query here. And you can see that now I have very fewer labels. I have only the labels that I ask for. This is name, label 0, label 1, sorry, host group, and server. The values are the same. So this is a trick to minimize the number of labels that I see. Okay?
Oh, question.
Yes.
So you say that this is at that instant. That's the metric. So if you run this the next minute, you get a different value or different results.
Right. Right. I get a different instant vector. So this is what
can you get results from the past?
Yes, I will show it. Here, I did, again, this trick of minimizing the label I see, and then I added an operator and a scalar. I asked to see only the instants that are bigger than 0. And I also used this regular expression, give me either the value new campaigns or task name. That's a regular expression. So I got a new vector with 4 items, and that's a new instant vector with its own values. It shows the value right now in this instant. I can see it in graph because it's a counter. You can see that the graphs, it rises and then resets. increments and then resets, increments and then resets. You can change the time frame of 1 week or more. You can see here we didn't have a reset, and then it resets. As I said, you can do a simpler query and you will get the same result. Same instant vector. And as I said, you can use regular expression like here. This is the operator. And here you got 2 series and 2 values. You got an instant vector with 2 items. Regular expression. You can use every regular expression that you can think of that supports Golang regular expression.
I think we got all of them.
I got another one. Water 0 and not 0 or 9 to 3 to 9. Okay, just for the fun. You can do everything you want. You can also negate. You can tell, I want everything, but besides water 101 or water 103. So you can combine. You can say, give me all the servers between water 101 to 109, but don't give me back the label value water 103. How many labels values did I ask for?
9.
Here is 9 minus 1, right?
So so if you put multiple expressions for the same label,
it works.
There is an AND operator to them?
Yes, yes. Cliff, you asked, right? You said, if I want to see in this instant, a week ago. And in Taboola, it's very useful to see what happened in the last Sunday. So you just add a keyword offset, and then you put 1 week, 1 minute, 1 hour, 2 weeks, whatever. Now, I want to talk about the rate function. This is a very, very important thing to understand, that a counter without a rate is not very useful. But before that, let's define what's a rate. A rate is a unit in time. So I mean, like, there's a counter, and then if you divide it in a duration, you will get a rate. For instance, MPH, bytes per second, bit per second, messages per day, QPS, TPS, speed, okay? If you have a counter, it's not useful without a rate. Let's see what happens when you see a counter. You see that your graph goes up and then resets, goes up and then resets, goes up and then resets. So you cannot use it. It's not useful. You don't know what's the rate. And it happens because you would only increment. So how do we get, actually we saw this graph, right? We saw this counter already. How do we get from the counter to a rate? For that, we need to understand a new terminology called the range vector. So we already saw this query, but now we add a time range into it before we use the rate function. Let's see what we get. We got back a range vector. What is a range vector? We have 5 minutes for each series in the vector. That's the first item, second item in the vector, third item in the vector. And for each and every item, we got all the samples that were scraped from the service. And this is the timestamp. So in this last 5 minutes, we got 338 up until 340. So it was incremented by 2 in these 5 minutes. This series were incremented by 2 also, and this series were incremented by 4. So this series represents a faster, a higher rate server, 103. Water 103 has a higher rate. So we have a range vector. Each and every result is a range.
Question.
Just a second, another thing, and I will return to question. Now, if we use the function rate on this expression, it will give me back an instant vector. How does it work? It takes the first sample, the last sample, and divides it into 300 seconds and gives the rate per second. I'm ready for questions.
Yeah, so how are there 6 values if Prometheus pulls every minute?
They are between 4 to 6 values because sometimes Prometheus is busy and didn't scrape, and maybe Prometheus missed a scrape. Now, the second very important function is sum. Why we need the sum? It's like a group by in SQL. We already saw it. Usually you will do sum over rate of a 5 minutes. And sum, as I told you, eliminates all the labels. Sum of a rate, again, gives an instant vector. Rate also gave an instant vector. So, that, by the way, do anybody feel like this? If you feel like this, you can talk to me afterwards. I will explain this slide. Or you can ask right now. So I'm doing a sum of a rate in the 5 minutes, and the sum caused the labels to disappear because it understands the sum that I'm not interested in any dimension. If I want to add a dimension, I can use, instead of sum, for instance, average, and I can tell you, give me this dimension, label 2, group by label 2, and do an average. So label 2 is actually those values. And by the way, you see that I have a space here, so it didn't give me the Safari. You see the result.
So the sum is summing by everything, basically, right?
Right. Each and every series in the vector.
So it is just a global sum, period.
Right. If I have, oh, sorry.
Say what?
Say what? If I had done average by, without by, average of this vector, I would have get one series.
What if I want to do a sum by label?
So you just sum by a label.
Ah, sum by, right, there you go.
I just want to give you another aggregation as a bonus, right?
Thank you.
Not to remember sum. You have minimum, maximums, average, everything.
Okay. So basically
Yes.
you end up having very similar aggregation that you have in SQL, more or less.
Yes, very similar. But very, very much stronger. Much stronger. See, for instance, count. Count here counts the number of series. And it can tell you that each TRC server sends this metric only once. So this number, 173, is actually the number of the servers. I have also operators. You already saw the operators. Let's see this example. I sum by those two labels. This query, I'm using regular expression here from one server. So, but for this example, I will use the sum just to eliminate the labels, the extra labels. So this is the result of this query. 1, 2, 3, 4, 5. If I add this operator greater than 300, what will happen? It will eliminate these two series, and I will get only 3 items in the vector. If I will add the operator bool, it will replace the result of the value 0 for false and 1 for or true. This is very useful in alerting. And then I can multiply. Give me all the series, which in this instant is bigger than 300, and multiply it by 10. This is very useful when you want to scale your data.
Earlier, when you said have two series, one of a counter and another series of the sample size, will you explain how to merge those two series into one?
This is actually for a question. The answer is in the advanced session. And I have also an advanced session if you want to operate between two series. But I can show you that I already showed it to you. So this is a series, right, Arturo? Divided in another series, right?
Okay, but what if one of the series doesn't have, if it's missing one value? Like if
Yes.
the vectors are not of the same size?
If it's missing, if the labels does not match, the series is dropped from the operation. You need a full match between, it's wrong. You need a match between the labels. Either an explicit match or you make it match. You can see I can send you the advanced presentation, or you can see in the documentation how does the matching between labels happens. Okay. You exactly asked the questions in the moment that I wanted to talk about it. Amazing. Arturo, did I answer your question?
Yeah, I think so.
Okay. So let's see how does it look in Grafana, right? We're talking about Prometheus, but what about Grafana? So in Grafana, like I said, you need to choose your data source. So this is zoom in. If you want the cross DC, that's the name. Okay. So for instance, this query, sum by 3 labels, rate of a counter of 3 servers multiplied by 60 to get a rate by the minute and not by the second, right? Because rate gives you by the second. So if you multiply it by 60, it will give you by the minute. So this is how it looks in the Prometheus UI or the Thanos UI. And this is how it looks much nicer in the Grafana. Black, stylish, very nice. Little bit different, but very similar. In Grafana, what you have the ability to customize your legend. By the way, before that, if you want to go to the Prometheus UI, you have a special link here. You see this link? You can click on it and you will go to the Prometheus UI. And here, this area is the legend area. I'll show you how to use it. You can take one of the labels using a mustache, that's a double curly brace, and you can use each and every label with additional literals between them or around them, and this is what you will get. Sorry. You will get the value of the label and the value of a label with underscore between them, like I did in this template. It's like templating language. Alerting. We have 2 options to use alerting. Alertmanager, which comes with Prometheus. It's a robust, hardcore alert system. Very, very, believe me, very, very strong, okay? And there is Grafana Alerts, which is easy and nice and it has less features. Let's start with Grafana Alerts. So you define a name for the alert. You tells it to evaluate every 1 minute. If for 20 minutes, the condition minimum of series A is below this number, or minimum of series B in between 5 minutes and now is below this number, or this, or. And if this happens for 20 minutes straight evaluated every 5 minutes, then send a Slack to SPD and PD for SPD, and with this message, with this runbook and this dashboard. These are the queries for SPD, minimum of this, this metric by topic. Minimum of, you can see the by can be at the end also, not only at the beginning. Minimum of this retention by topic. If the minimum is dropped below these numbers, you will get an alert to Slack and PagerDuty. And the last slide about this is the list of the alerts. Here, you can click here in Grafana, you will get list of alerts. Questions, please.
These ones, are they, where are they run? Like
Grafana.
I see. We have.
Now let's see the Alerts Manager. That's in Puppet. You define rules. You write your query here. And there are the labels and the annotations. So that's a query. If it's above 600,000, so if it yields results, it will fire. If it happens for 6 minutes, it will fire a PagerDuty. Sorry, it will fire a PagerDuty to this team and in this Slack channel. And I can tell you again, Alerts Manager is super powerful. It has like crazy features. Let's do a summary and then I will be open again to questions. What did you get today? You tasted a little bit Prometheus QL. You saw the architecture. You saw how to find your metrics using the label values and the label names. You saw that you have two options of alerting. You saw that the Thanos UI and Prometheus UI, how it looks like, and you understand a little bit that you need to choose your Grafana data sources very wisely. Thank you. So thank you very much for listening. And if you have further questions, please go ahead. I'm here for you. Thank you.
Thank you so much.
Thank you, Tal.
Thank you.
Thanks.
Bye-bye.
How could we clap in Zoom?
Yeah,